Hi, this is an AP Chemistry video, topic 4.5, and this is part 3. I'm breaking this into pieces because it's got some pretty long problems in it. So this question here is a typical AP question where we're going to have to figure out the limiting and how much volume of hydrogen is produced. That's pretty straightforward. And then letter B, you just have to be able to predict how the following changes, would they increase the volume of hydrogen? And I'm actually going to answer that more as if they increase it, how, what is the volume of? So I'm actually going to do the calculation. So the first thing you're going to do is let's determine just convert to moles first. So I'm given 50 mils of 1.0 molar HCl. And that is equivalent to 0.0500 moles of HCl. And then I'm going to take my grams of zinc, use my molar mass, and then that gives me 0.359 moles of zinc. Now I'm going to determine the limiting. So I am going to do both. You can do just one if you want. So if I take my moles of HCl and convert it into moles of zinc, I get 0.0250 moles of zinc. And you can see that I do have that amount, and I have more than I need, so that will be my excess reactant, and that means hydrochloric's my limiting. But let's show the other way too. So if I take my moles of zinc and convert it into moles of hydrochloric, I'm going to get 0.719, I think, moles of HCl. And you can see that I don't have that much. That means this is my limiting. I'm not going to use that number for anything, and this is my excess. So I'm going to answer the first part right here. I'm going to bring this down. Kind of got things in the wrong spots here, but maybe I'll move that and then move this one down. This one down. Okay, I'm just trying to give myself enough room. So in this question, they just want to know now how much volume of hydrogen is produced. And they are giving us STP, standard temperature and pressure. So because of that, we can assume that 1 mole of any gas is going to occupy 22.4 liters of space. You could also calculate just the moles of hydrogen and then plug into PV equals nRT using those values, but I like to do it with stoichiometry. So I'm going to start with my limiting. And I'm going to use my mole ratio, 1 mole of hydrogen for every 2 moles of hydrochloric. Up above, you can see those are the coefficients. Then 22.4 liters is how much 1 mole of hydrogen or any gas would occupy. So when I do that, I get 0.562 liters of hydrogen. So now we're going to answer part B, where we're going to be changing things. So the first one is we're going to double the mass of the zinc. So what effect, if any, will that have on the volume of hydrogen produced? And it will have no effect because zinc is already the excess reactant. So it's already in excess. You're just adding more. So that's not going to have any, anytime that you're adding more of the excess reactant, it's not going to affect anything other than you'll just have more leftovers. But the next question, if we double the volume of the hydrochloric, So instead of 50 mils, we have 100 mils. We want to still make sure, well, we want to redetermine which is our limiting reactant and which is our excess. So this gives me 0.1 moles of hydrochloric. And if you remember, I'll grab this up here. We know how many moles of zinc we have to start with. So I'm going to do a limiting problem again. So I am going to take my moles of hydrochloric and convert to moles of zinc. 1 mole of zinc for every 2 moles of hydrochloric. So that gives me 0.0500 moles of zinc would be needed in order to react with all of this new double volumed hydrochloric. And you can see that we do not have that much. So that tells us that the zinc is our limiting now, and the hydrochloric is our excess. But we're not going to use that number. We could also, let's go the other way and make sure we are in agreement. So if I take my 0.359 moles of zinc, convert to moles of HCl, I'm going to get 0.0718 moles of HCl, and I now have 0.1, so I have plenty. So again, that reaffirms that the excess reactant is the HCl and the new limiting reactant is zinc. So if that's the case, then I am going to take the amount of zinc that I have and convert to moles of hydrogen. And I'm just going to turn my paper here. So I know my mole ratio is 1 mole of hydrogen for every 1 mole of zinc. And then I'm going to use molar volume again. And when I do that, I get 0.804 liters of hydrogen. So by doubling the volume of the hydrochloric, we increased the volume of hydrogen produced to 0.804 liters. Let's do another problem. The next one is the last part of the problem, is doubling the concentration of the hydrochloric. So the hydrochloric is 1 molar. So now the hydrochloric is going to be 2 molar. So again, let's calculate how many moles of HCl. So now my volume is back to 50 mils, but my molarity is double. And so that gives me 0.1 moles of HCl. And can you see how this is identical now? What's going to happen by doubling the molarity? Now the limiting reactant is going to be the zinc, and then you're going to be able to make 0.804 liters of hydrogen. If for some reason you didn't have that, you would want to reestablish who the limiting reactant is. And I can do that with you. So I'm, if I were to take my beginning moles of zinc, and I know I just did this up above, but you could see that I would need 0.718 moles of HCl, and I have 0.1 mole, so I know that the hydrochloric is going to be in excess and the zinc is going to be limiting. So now that I know that, just like up above, I would take my limiting reactant and convert to hydrogen moles, and then multiply by the molar volume. And I would get still the increase in the volume from before is increased up to 0.804 liters. Let's do another problem. Similar. So this one, I would recommend that you try and then, watch the video and see if you agree, or look at the completed notes that I have on Schoology. But I should have had this ready. Sorry. Let's do this one. So we have, it's a really very similar problem. We have a combustion reaction of propane producing water and carbon dioxide reacting with oxygen. So you can see that we're given 44.1 grams of propane. First thing that we always do is convert to mole. So I have about, it rounds, I think it's 0.999 something moles, but one mole of propane. And then if I take my, whoops, this is 0.1. Are they both the same amount? Yes, grams of oxygen. And I divide by 32. That means I have 1.38 moles of oxygen. So now that I'm there, if I want to determine my LR, I'm going to do it both ways for you. So if I want to react all that 1 mole of propane, I would need 5 moles of oxygen. And you can see that I don't have that. So I know the oxygen is limiting, the propane is in excess. Let's go the other way just to confirm. So if I were to start with my moles of O2 and convert that into moles of propane. When I do that, I get 0.276 moles of propane. And you can see I have plenty. So that will be my excess, and the oxygen's my limiting. Oh, and don't forget, I usually cross that out because that number will never get used again. All right, so now that I know my limiting, they're asking me for grams of CO2. They're giving you the standard conditions, so you could easily use 22.4 to figure out the volume, but they want mass, so we don't really need that information. So starting with my limiting, I'm going to convert to moles of CO2, use molar mass of carbon dioxide, and then I get 36.4 grams of CO2. So now let's do the part. Again, they are asking you what effect. So we're going to quantify this. If there is a change in the amount of carbon dioxide produced, we're going to calculate it. So first, what effect would doubling the mass of the propane have on the, how many grams of carbon dioxide? This is another one where there's going to be no effect, no change in the amount of carbon dioxide because the propane is already in excess. But let's see if I can grab it without, I'm going to bring this up. So now let's double the mass of the oxygen. So originally we had 44.1 grams. Now we're going to have 88.2 grams of oxygen. So now I have 2.76 moles of oxygen. So I would want to redetermine the limiting. And I am repeating quite a bit here. Like I'm going to I don't know. I'm doing more work than is probably needed. I'm going to show you both ways to determine the limiting. You only need to do one. So I'm going to take my new moles of oxygen and convert it into moles of propane. And I get 0.551 moles of propane. And if you remember from up above, I have 1 mole of propane. You guys see right here. So I have more than enough. So the excess reactant is going to stay propane, and the limiting is going to be the oxygen. You could also go the other way by taking our amount of propane, converting it back to oxygen, and then we get 5 moles of oxygen. And we do not have that. We only have 2.76. Not going to use that number. Oxygen is limiting still, but now a different amount. So my calculation to calculate the amount of grams of carbon dioxide, I'm going to start with my 2.76 moles of oxygen, convert to moles of CO2, use molar mass of carbon dioxide, and then we get about, I think, 72.8 or 9 grams of CO2. I'm going to stop there. That was the end of part 3, topic 4.5.